various simulators first. So this is the RTDS simulator. So we have 6 racks of it. Okay. And we have different wind emulators, and but basically we work using the RTDS and this cyber physical test bed that we develop. So we procure different IEDs equipments, and then we develop the cyber physical test bed, and we integrate it with the RTDS. Okay. So in this, we have 3 PMUs. So this one, and this one, we have 3 PMUs. So we don't call it as a PMU, we just call it as a Axion, because it can work as a PMU. Also, it has inbuilt RTAC, also real-time automation controller. So we can develop our algorithms also and dump it in this. So it is a multi-purpose device. So that's why we call it as a Axion. But here we are using it as a PMU. So we have 3 PMUs. And then this is a distance protection relay, transmission protection relay. So this SCL 311C. So most of the devices are from SCL here. Okay. And then this is the GPS clock. All these devices are time synchronized using the GPS clock. I will show you the connections at the backside when we go there. And this is the PDC. So all these PMU devices, 3 hardware PMUs here. And here we have a GTNet X2 card also. Okay. So in using that card, we can have multiple software PMUs also, 8, 24 like that. So let's say we design a power system network, let's say 9 bus, 14 bus, or let's say Uttarakhand has some 24 buses. So let's say we design that in our RTDS using the RSCAD software. There we design the power system network, and let's say from a particular bus, we want to collect the data and give it to a PMU. So let's say in a substation, we have a PMU installed there. So using the CTPTs, we take the analog signals from RTDS using GTAO cards. Okay, it is also installed in this rack. So using the analog GTAO card, we take the signal out of the RTDS. But the signal coming out of the RTDS is maximum plus minus 10 volt. But these PMU devices, it requires minimum 150 volt to sense the voltages and currents also. It is larger, but it cannot sense 5 volt or 5 ampere of current. Okay. So we need to amplify it. Okay. So for that, we are using this CMS 356. It is from Omicron. So this amplifier we use. Okay. So three voltages and 3 currents we give it to this amplifier. We can give 6 currents also based on our function. If we are only working on the fault and protection functionality, we generally give 6 currents. Okay. And here we are giving 3 voltages and 3 currents. And after amplification, we are giving to these PMU devices. I will show the connections in the backside. Okay. Also, we have this software defined network switch. Okay, as Professor Sidhu has told that we can do the networking, routing, and all those functionalities in a software also. No need. Here in the backside, it has different ports, but from which port it will go to which another port, that we can do it in a software also. Currently, we are not using it. We have a separate 8-port switch at the back. There on that only we are using, but we can use this also. And finally, this is an RTAC. So the RTAC provided in these Axions, they don't have much computational capability. So even if we write a small if else 10 lines of codes, it takes around 10 minutes to dump in this Axion. So we have a dedicated RTAC also here. So there also we can write our programs. There also computational capacity is not that big. We cannot write 1,000 lines of code there, but it is comparatively larger than these Axions. Okay. So these are the devices that we use in our cyber physical test bed. And then we will go to that side where we have the connections. I will show you the connections. Okay.
See,
Yes.
CDS, you are giving output of RTDS,
Yes.
output, analog output.
Analog output signals.
You amplify this.
Yes, using this amplifier.
Does this have this log input?
Yes. So, as you can see,
From that back.
no, you can see there it is here. I think it is at the down, I think. CBS have a plus or minus 10 volt capability. Yes. Input and output. Yeah. So this also has a mapping, also color coding mapping. So this is for A channel, B channel. So same thing, we map it into here and it just amplifies it. And three-phase voltage, how we take out, it is at the back side. That I will show you. That's scaling from 0 to 10.
These are the outputs of RTDS.
No, the GTO card is at the back side. Okay. These are the DI, digital input. So from relay, if we give digital signals into the RTDS, that we use this digital in channels. We have 24, something like that. Okay. But AO, it has only 12 channels. We only use 6, 3 for 3 voltages and 3 currents. So 6 we are giving it to here and then we are amplifying it.
What if we have to simulate more EMUs?
Yeah, so that is we should have more amplifiers, or you can go directly using GTNet card, because
Direct GTN card.
so that is connected to switch and switch is connected to this PMU. So directly through communication channel we can, but that is a kind of a simulation.
Yes.
There are no hard signals there.
So that's we directly connected to this one.
Yes. Direct all these extrions. Yes, PDC. Directly PDC. Yeah.
So we can mimic that there are n number of
Yes.
EMUs out.
Yes. So that we can do here.
The modern substation. Merging units are there,
Yes.
which will convert the data to digital numbers, and that data will be put on the net. So,
Yeah.
so simulating it using software is okay.
Yeah.
There's nothing to do. You will get the same result.
Yes.
Because something that is very possible. It will help us more than 30 minutes.
Yes.
For studying and, and analysis, all that.
The here drawback is only we can give it to only one PMU. So if we want to use 2 hardware PMUs, we need another amplifier. So that is the problem.
You have another amplifier.
Some
other one.
Yeah.
But doesn't PMU have that capability of digital inputs?
Digital input it has. You can see in the backside it has digital.
If you use the digital input,
But
you go for
digital signals, then in the RTD,
from RTDs through the digital signal.
that is not same as analog voltages and currents. I think digital signals.
No, like
We can.
I know about opolactic only. Just like we can fetch that PWM pulse as a digital input, and like scaling through like this amplifier through, we can convert into the analog.
Okay.
Otherwise, we can directly fetch through analog. Signal to PMU digital signal. So we need a okay.
Yeah.
From segments,
Yeah.
See, this is the thing with power system. It's all, everything is mixed up. We have analog relays, we have solid state relays, we have microprocessor relays, we have merging units, we have PMUs. So you have to work with all of them. Right? So if you have the new technology.
Just hold it easy.
Yeah, the newer technology, if you have merging units, so what we have done is basically out of PMU, we have taken out the small part that takes analog signal and converts to digital signal. And then digital signal, the digitized values goes to another unit, whereas PMU has everything together. So you have to give it to analog signal. And inside it, it will convert to digital signals and do the phasor calculations and so on. Whereas if you have a merging unit, you can separate that out. And the role of merging units is to take analog data and just sample and give you the digital numbers, right? Yeah.
Okay, we will go to that side now. Okay, they need some 2-3 minutes to set up there also. Just to, okay, yeah. Okay, so in this, if you can see, we have come from RTDS through GTO card through the to this amplifier. Then through this amplifier, if you see this cable coming out, it has like this 3 voltages and neutral, and this is 3 currents and neutral. So from amplifier we give it here, and these wires are going to the CT module of the PMU. Okay, so here this is the CTPT module. So this is PT and this is CT module. Okay, so like this, similar for all the cases. And then this is the iRigby cable for the GPS connection. So this is GPS clock is connected to this PMU. Use this has one input. No, it has 4. It's an out. All are out. All are out. And one antenna should be connected. This is antenna, sir. So that should be in. Yeah, that is connected here. I think this one. Okay. Yeah. So one antenna is connected to this GPS clock, and it has 4 outputs. So 3 PMUs we have connected. Okay. So this cable is connected, and also the Ethernet cable is connected to. So all this is the hub of our test bed. So all these PMUs, PDC, relay, and RTEC are connected to this switch, and this switch is connected to the college network, and we have one P also connected to this college network. So all the softwares which to run these, I have shown one software QuickSet yesterday, and then we have accelerator, RTEC, then RSCAD, everything is there in that PC that we use to configure the devices. Okay. So now we have given it to the PMU. PMU is connected to this switch, and the PDC is also connected to this switch. So like this, how we configure it, I will tell you in the next session after 4. So like this, the physical connections are being done. Then this GPS clock is also connected to the GT sync card, which is there in RTDS. So in that GT sync card, it is to synchronize the RTDS with this GPS clock. So if we are using the GTNet card and we have software PMUs in there, so there we need the GT sync card to synchronize with the GPS clock. And then we have this RTEC that I told you. And then the same PC, we have this NetSim software also, that is we are using to create various types of attacks. So different attacks that we will see in the tomorrow session, but settings of all these things we will see after 4 p.m. And yeah, this is the everything we can let to show. Any doubts? This is how we are doing.
Why should I time sync with RTS required GT sync card?
GT sync card.
For the virtual PMUs.
For that software PMUs or virtual PMUs.
How many virtual PMUs we can control?
I will show you. There are 2 blocks. One is 8 GT PMU 8. It is written. So there 8 PMUs we can convert. There is also 24 also. So at a time 24 also we can configure. But mostly in the PDC we can receive only 8 at least. Yeah. So PDC is capacity. So that's how.
Virtual PMUs, any make can be configured?
Any
Make or some.
that is not a make of
specific.
that is not a, it is a virtual PMU is like it is from RSCAD one.
It should take some like
It's just
SEL make.
no. It doesn't ask any make. It just asks.
It gives the same feature to the.
Yes. It works as just as a PMU. It is calculating the phasors and getting time stamped by the GPS clock, and just it is saying sending the phasor values. So like this.
And yes, to go listen to the test. Huh.
So we'll be simulating this attack tomorrow.
Yes, attacks I will simulate tomorrow. Today we will just see how we can set up a wide area monitoring system. Means we can have different. We will share. Means one PMU to PDC connection. I will show you how we can see the waveforms in the monitoring software, and the goose communication also we will see. We will trip. So this HIL loop we will see today. Okay.
Wires are in already.
All today only we'll see.
Okay.
Just how the data looks like, synchrophasor data, goose data, how it looks like, we'll see in the Wireshark today only, and attacks we will see tomorrow. Pause करो.
We,
Hmm?
not give me the use config, compatible. That's our.
कुछ तो कर रहे हैं.
That's